Good morning dear students, welcome back. I am your physics professor Dr. Nagraj. So this is a continuation of model paper discussion. In the previous video I was talking about module 2, that is questions from quantum mechanics chapter. I have already discussed few questions on modern physics and quantum mechanics. Here is the next question. This question is bit lengthy, as I told in the previous video. It consists of a very lengthy derivation, that is particle in a one-dimensional potential well of infinite height. Well, I already explained the concept of eigenfunction and eigenvalue. Well, I just revised the concept of eigenfunction and eigenvalue. Then I proceed with the derivation of expression for eigenfunction of a particle inside the potential well, whose width is a and height is infinite, with using the method of normalization. So this is one of the most expected question. Eigenfunction means a wave function which is having a single value, finite value, and first derivative is always continuous. And when the eigenfunction is operated by some operators like energy value operator or momentum operator or spin operator, you get a definite answer. That answer, that value, that number is called eigenvalue. So here is the definition. If a wave function is single valued, finite, and its first derivative is continuous everywhere, then it is called eigenfunction. When eigenfunction is operated by some operators, a definite value is obtained and this value is known as eigenvalue. Well, I explained this also in the previous video. Let us proceed further. I consider a particle in one-dimensional potential well. Look at this diagram. So this is the particle. It is allowed to travel only along x-axis. So it moves along x-axis, goes like this, like this, like this, like this. And the well is infinite height. So it is height is infinite, h is infinite, but width is finite. And the assumption, some assumptions are made. Both the walls are rigid. This wall is hard, this wall is hard. When particle is moving to and fro, it is going to hit the wall each time. When it hits the wall, it rebounds immediately. So it won't stay there on this wall, it won't stay there on this wall. By chance, if the walls are loose, means if they are not rigid, hard, something like mud wall anta andkoli, then when the ball or particle hits the wall, the ball gets impinged into the wall, means the ball gets stuck to the wall. There is a possibility of finding the particle on the wall. So probability on the wall is not zero when the collision is not elastic, when the wall is not hard. But I have assumed that wall is hard, collisions are elastic, therefore particle cannot stay here, cannot stay here. So probability of finding the particle on this wall is zero, on this wall is zero. Outside the well, there also zero. Inside the well, it is not zero. So like this I have made some assumptions. One more assumption, as long as particle is inside the well, okay, its energy is minimum, and the energy I take right now as zero energy, right now, as of now, in the ground state. But it cannot come outside. If at all it want to come outside, it has to possess infinite potential energy. So outside the well, potential energy is infinity, inside the well, potential energy is zero. Okay, now all these things you write in one or two lines. Like, consider a particle of mass m present in one-dimensional potential well of finite width and infinite height. Walls of the well are assumed to be rigid. This is what I told you. Particle is restricted to move only along x-axis, that is from x equal to 0 to x equal to a. So this much whatever I explained now, that is there in the wordings. Also boundary conditions or assumptions. Psi equal to 0 and v equals to infinity outside the well. I told you no, ಹೊರಗಡೆ well in the ಹೊರಗಡೆಗೆ particle ಇರೋದಿಲ್ಲ, therefore probability is 0. Outside, if at all particle wants to come, its potential energy must be infinity, v equals infinity anta. Next, psi is not equal to 0 inside the well, and psi equal to 0 for x equal to 0, x equal to a. Equal to 0 means on this wall, equal to a means on this wall. See, the wall has got two well has got two walls, this wall and this wall. From here to here the distance is a. So this wall is at x equal to 0, this wall is at x equal to a. So all these things are there in the boundary conditions. So these boundary conditions are very important. I think 1 mark definitely is reserved for writing the boundary conditions. So marks division will be like this: explanation 1 mark, boundary condition 1 mark, diagram 1 mark. 3 marks already there in your account now. Okay, go ahead. First let us take case 1. Outside the potential well we will take. Outside the well, as I told, potential energy is infinity. So Schrodinger wave equation, d square psi by d. You must know the Schrodinger wave equation. to solve this problem. D square psi by dx square plus 8 pi square by mh square into E minus V psi equal to 0. This is your Schrodinger wave equation. In this Schrodinger wave equation, substitute V equals infinity. So you get the second equation. D square psi by dx square as it is irutte, 8 pi square m by h square as it is will be there, E as it is, in place of V I write infinity, and psi as it is equal to 0. Okay, now you just think of the solution for this. RHS is already 0. When the LHS becomes 0? Only when psi is equal to 0. So when I put 0 here, 0 into anything is 0, and when I put 0 here, differentiation of 0 is 0, so that the LHS also becomes 0. So LHS 0, RHS 0, it is possible only when psi equal to 0. So adanna nanili wordings alli bardidini. Possible solution for this equation is psi equal to 0. That means psi equal to 0 is nothing but probability is 0. That means outside the potential well there is no particle. Probability of finding the particle is 0 outside the well. So this is the conclusion what we can draw from first case, means outside the well there is no particle, right? Now let us take up the second case. Now we are inside the well. We cannot say inside the well also probability is 0 because particle is very much there inside the well. So psi equal to 0 is not a Eigen solution now. Okay, let us proceed. Inside the well we shall put V equal to 0. When you put V equal to 0, Schrodinger wave equation becomes like this: d square psi by dx square plus 8 pi square m by h square into E into psi equal to 0. So that means that means in this all case also psi can be 0. But I don't want to take psi equal to 0, because if I take psi equal to 0, I have to say there is no particle inside the well. But particle is very much there. Then how can I say there is no particle? Haudalva? So psi equal to 0 mathematically correct, but physical interpretation cannot be given now. This is the difference between physics and maths. Mathematics, it is a tool. Okay, I make use of the tool whichever is suitable for me. Psi equal to 0 was suitable for me in the previous case, because if I had taken psi equal to 0 earlier, I would have given proper interpretation. Now I cannot say there is no particle inside the well, because particle is very much there inside the well. Therefore psi equal to 0 is not a proper function, is not an eigen function. Then what? That we will try now. We will try. Okay, for that we have to do some mathematical operations. First I make one substitution. K square equals so much. Then the equation, this equation becomes d square psi by dx square as it is, plus this whole thing k square as it is, psi as it is, equal to 0. Okay, dear students, this is a second order differential equation. For this equation we can find the solution. This particular step, finding solution, I will skip. Okay, it is not necessary to do all the steps in detail. Okay, write straight away the solution, and the solution is given by equation number 3. That is psi is equal to c cos kx plus d sin kx. Dear students, I will share the notes or answers for each and every question after I finish all the modules. I will give you the Google Drive link. You can download it. It will be available in description box once I complete the discussion of the model paper. And please do all these derivations once or twice. Any derivation for that matter, it is better to practice. Okay, this is one of the most important derivation. It takes nearly 10 minutes, I tell you. It nearly 10 minutes. You might have already observed this in your classroom. Your teacher might have told you in the class. Normally we teachers take 1 hour to do this derivation, because you have to explain it in a detailed manner. Okay, come on, let us proceed. In this solution we have the two constant values c and d. We have to find out c and d. How to find c and d? Dear students, c can be 0, d can be 0, but both c and d cannot be 0. Sir, why sir? Why? You only try to convince. Nodi, by chance C 0, D 0, eradu 0 agbitre, if both of them become 0, psi equal to 0. What is the use? I told you psi cannot be 0. So if you take C and D both are 0, there is no meaning in writing this solution. So therefore I can confidently say either C alone is 0, D alone is 0, but C and D definitely are together ಆರ್ ನಾಟ್ ಈಕ್ವಲ್ ಟು 0 ಅಂತ ಹೇಳ್ಬೋದು. 0 ಇಲ್ಲದೆ ಇರಬಹುದು, ಬಟ್ 0 ಆಗ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ ಎರಡೂ ಕೂಡ. ಇರ್ಲಿ ನೋಡೋಣ ಅದು ಏನೇನು ಬರುತ್ತೆ, ವಿ ವಿಲ್ ಟ್ರೈ. ಓಕೆ, ನೌ ಕಮ್ಸ್ ದ ಡೆರಿವೇಶನ್, ಕಂಟಿನ್ಯೂಯೇಷನ್ ಆಫ್ ದ ಡೆರಿವೇಶನ್. Well, I have taken the solution c cos kx d sin kx. Now I impose first boundary condition. Put x equal to 0, psi equal to 0 in the above equation. Again agute 0 is equal to c cos 0 because x I have taken 0 plus d sin 0. Sin 0 is 0, cos 0 is 1. Alge c is equal to 0 agute. I just write and show you. 1 minute, I will just write and show you how actually it becomes 0. See here, in this case c cos 0 plus d sin 0 is equal to 0. That is c into 1 plus 0 equal to 0. So c is equal to 0. That is this answer, this one. Okay na. Next again put x equal to a and psi equal to 0 in the above equation. Suppose if I put x equal to a, then c cos ka plus d sin ka is equal to 0. Anyway c is already 0 plus d sin ka equal to 0. That means d sin ka equal to 0. That is what I have here, d sin ka equal to 0. Okay, well let me proceed further. I just erase this part. Now d sin ka is 0. Now we know d cannot be 0 because already c is 0. Therefore I can say only possibility sin ka equal to 0. Correct? So already I proved that c is 0. Now d cannot be 0. D cannot be 0 ಆಗಿರೋದ್ರಿಂದ in this equation I can say comfortably sin ka equal to 0. When sin ka equal to 0, ka equal to sin inverse of 0. Therefore ka equal to sin inverse of 0 means n pi. Got it? So ka equals n pi, k equals n pi by a. I hope you are following. Without writing the steps, you can I am not able to write it, but I am displaying all the steps here. I hope you are able to make out. Okay, well let us proceed further. Now n cannot be 0. N can take only values from 1, 2, 3, 4 etc. Okay, now I have k like this. What about equation number 2? Just I will go back to previous slide. Take a look at this equation. K square is equal to 8 pi square me by h square. In the place of k I should put n pi by a. That is what I am doing here. Okay, in the place of k I am putting n pi by a, and k square means n pi by a whole square. I just make small mathematical operations and then I take all these things this side, then E becomes n square h square by 8 ma square. So this is my energy equation. This is also called as energy eigenvalue. Okay, now you take any one value for n. Better you take n is equal to 1. If you put n is equal to 1, this becomes E0. Why sir 0? I already told in my previous video in one of the numerical, n is 1 means ground state, n is 2 means first excited state, n is 3 means second excited state. So n equal to 1 corresponds to 0th state, means lowest state. Next first excited, second excited, third excited, like that it goes. Okay, so that is why I am writing it as 0. Okay, this is h square by 8 ma square. It is also called as 0 point energy. Okay, 0 point energy or ground state energy. Now go back to equation number 3. Equation number 3 nalli c jagake 0 haki first term becomes 0. In the place of sin k, d as it is you retain, we don't know d. K in the place of k write n pi by a. Then you get this formula, psi is equal to 0 plus 0. I am not writing. Straight away write the second term, d sin kx enidiyala, that I am writing d sin n pi by a into x. Okay, n irodrinda in the place of psi I write psi suffix n, right? Psi n is equal to d sin n pi by a x. Now we have to find out the value of d. Unless you find the value of d, you cannot say wave function is eigenfunction, because eigenfunction property is it should be single valued, it should be finite, okay, its first derivative must be continuous. Now I don't know whether it is a single valued or it is going to be imaginary or zero or ಏನಾಗುತ್ತೆ ನನಗೆ ಗೊತ್ತಿಲ್ಲ. Unless I know d value, I cannot arrive at a conclusion about the psi. I cannot call it as eigenfunction. So therefore I have to find out the d value. For finding the d value, I adopt this method. This is called normalization. This is very simple. Now you have to do integration, that's all. According to normalization, this is the condition: integral of psi square dx equal to 1. Okay, just there is one 0, that is actually not correct. I just erase this. Right. Now integral of psi square dx is equal to 1 and the limit 0 to a, because the particle is moving from this wall to that wall. Okay, so particle is restricted to move only along one direction. So that is why it is called as one dimensional potential well. Okay, therefore lower limit is 0, upper limit is 1. I give you, you can pause this video and you can integrate, or okay, I give you one more step, then you try to integrate. I have substituted for psi n here. Psi n is already in this case, it is available here, so directly take it here. Psi n andre d sin n pi by a x and whole square, and after that it becomes d square sin square n pi x by a dx equal to 1. This is something like sin square theta into d theta. You can take d square outside, it is not a problem because d is a constant, right? Then sin square theta is nothing but 1 minus cos 2 theta by 2. Okay, this is one of the trigonometric identity. So you make use of that particular equation. See, this is very lengthy. That's what I told you. It's very lengthy but very important. 10 marks assured. Oh, you can take it for granted. It is there in your account. If you practice this and if you write all these things, 10 marks 100% you will get. Okay, now 1 minus cos 2 theta by 2. That by 2 I have written here 1 minus cos 2 theta. See, in the place of theta I have n pi x by a into dx, that is equal to 1. Well, you integrate. I hope you know how to integrate. I will not take much time in the explanation of this particular part. 2 is taken outside, so it is d square by 2, and then I split this integral of 1 into dx minus integral of cos 2 n pi x by a into dx. Keep on integrating, okay, this becomes integration of dx, that is x, and then I apply limits. Upper limit is a, lower limit is 0. Next, integration of cos is sine of theta by whatever the coefficient we had, that. Okay, and then I am applying the limit simultaneously. Upper limit a, lower limit 0, right? Actually it is sine of 2n pi. Okay, I write it here, just 1 minute. It should be sine of 2n pi x by a whole thing divided by 2n pi by a. Okay, this 2n pi by a is taken to the numerator here, and in the place of x upper limit is applied, that is a. In the place of x lower limit is applied, that is 0. Okay na? So that is why I have this step, right? I just erase. I hope you got it, so I can erase this part. Then keep on simplifying. Upper limit and lower limit I have applied. Then next step, here a minus 0 means a only. Next, a by 2n pi as it is. Sine of, see, a cancel, I have sine 2n pi, sine 0 as it is equal to 1. So in the next step, it is d square by 2 as it is, a as it is, sine 2n pi 0, sine 0 0, so the second term full becomes 0. Okay, therefore I have d square a by 2 only first term, the second term full 0 agate, so d square by 2a equals 1 aito, therefore d is equal to root of 2 by a. This particular step you can make out. So now I have d value. Look at d value. D is not a 0. That's what I told you, d cannot be 0. Yes, d is not 0 now, and d is not negative, d is not imaginary. Now I can substitute this d value in this psi equation. I get what is called eigenfunction. This is my eigenfunction. So psi n equals root of 2 by a sine of n pi by a into x. I can comfortably and with confidence I can call this as an eigenfunction. So this is about this question. Okay, I hope you followed this. If you want, you just rewind this and go back and recall it and watch it once again and try to practice this derivation. Well, dear students, with this I move on to the next question. Show that electron does not exist inside the nucleus using Heisenberg uncertainty principle. See, this is one of the major application of uncertainty principle. We all know atom consists of nucleus, and inside the nucleus there are protons and neutrons. Electrons are simply revolving around the nucleus. The basic question is why electrons cannot stay inside the nucleus. What is the problem? What is the requirement? What is the eligibility for electrons to stay inside the nucleus? Actually, one team of scientists way back in 1930s were arguing that electrons do exist inside the nucleus, and during beta decay they are coming out in the form of beta particles. Like that they were arguing. Okay, you know radioactivity, alpha decay, beta decay, gamma decay. Alpha is nothing but helium nucleus, beta is nothing but electron. Okay, so electrons are coming from nucleus anta argue ಮಾಡ್ತಾ ಇದ್ರು. They were arguing that electrons do come from nucleus and therefore electrons are pre-existing inside the nucleus. Okay, and uncertainty principle gives convincing answer for this. According to uncertainty principle, it is impossible to see electron inside the nucleus. Electrons cannot stay inside the nucleus. That we have to prove now. So how to prove? First, I assume that there is electron inside the nucleus. Then I do some calculations. Then I compare the calculation with experiment. If experiment and my calculation do not match, my assumption is wrong. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? First I will assume that there is electron. ಒಳಗಡೆ ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ ಅಂತ assume ಮಾಡ್ಕೋತೀನಿ. Then I make some calculation. ಸ್ವಲ್ಪ calculation ಮಾಡಿ ಯಾವುದೋ ಒಂದು ಆನ್ಸರ್ ಬರುತ್ತೆ. That answer I will compare with experimental value. See, for us experiment is ultimate. If my calculation matches with experiment, then my assumption is correct. If it is not matching, I cannot say my assumption is correct, experiment is wrong. Experiment is always correct. So my assumption is wrong. Like that, this is what is called negative approach, right? Well, assume, this is what? Let us assume that electron exists inside the nucleus. And dear students, in PUC you all studied about nuclear radius. Nuclear radius is given by R is equal to R naught into a to the power of 1 by 3. Approximately nucleus size is about 10 Fermi. Fermi means 10 to the power of minus 15 meter, approximate size of the nucleus. So, if at all electron exists inside the nucleus, it must be there within this radius only. I just draw the diagram and show you. If at all electron exists inside the nucleus, say this is a nucleus, this is radius, so it must stay inside the nucleus within this radius only. Therefore, uncertainty cannot be greater than, it is always less than or equal to 10 into 10 to the power of minus 15 meter. Idu assumption, if at all it exists anta helidini. Okay, so this is what I have written here. So delta x is less than, delta x is less than or equal to 10 into 10 to the power of minus 15 meter. Now by assuming that delta x is less than this, make use of Heisenberg uncertainty principle. Delta p delta x greater than or equal to h by 4 pi alva, uncertainty principle. Adalli delta x anna ee kade kalisidini. I have sent delta x this side, so I have uncertainty principle in this form. Now substitute for h, substitute for pi, substitute for delta x, calculate delta p. The answer comes out to be 0.5 into 10 power minus 20. That means if at all electron inside the nucleus, it must have minimum momentum of this much. Minimum anta helta idini, not maximum. That means p is always greater than or equal to 0.5, cannot be less than 0.5. So that is a minimum momentum, if at all. Now we know momentum. With the help of momentum, we can calculate kinetic energy using this formula. Kinetic energy is equal to p square by 2m. M is mass, P is momentum, substitute and simplify, you will get the answer as 85 MeV. That means if at all electron want to stay inside the nucleus, it must have minimum of 85 mega electron volt energy. So this is the condition, this is the requirement. If electron fails to possess this energy, it cannot stay. Anyway, so from my assumption, I came to this conclusion. Electron ಒಳಗಡೆ ಇದೆ ಅಂದ್ರೆ ಅದಕ್ಕೆ 85 MeV energy ಇದೆ ಅಂತ ಅರ್ಥ. If at all electron inside the nucleus, its energy is 85 MeV ಅಂತ. ಈಗ if electron comes out of the nucleus ಇಂದ ಹೊರಗಡೆ ಬಂದರೆ it has to come with that much energy only. Like electrons property though, when it is coming out, it has to come along with its belongings. For example, you are in the classroom, with you have your school bag, lunch box, mobile phone, pouch, wallet, everything. It is your asset, it is your property. When you come out of the classroom, you have to come along with all those belongings. Ninna book, pen, bag, pouch, lunch box, mobile phone, wallet ಎಲ್ಲ ತಗೊಂಡೇ ತಾನೇ ಹೊರಗಡೆ ಬರಬೇಕು. ಸೊ ಇಲ್ಲ ಅಂತಂದ್ರೆ ನೀನು ಹೊರಗಡೆ ಬರೋಂಗಿಲ್ಲ, ಇಟ್ ಈಸ್ ಇಂಪಾಸಿಬಲ್. ಅಂದ್ರೆ ಹೊರಗಡೆ ಬರ್ತಾ ಇದೆಯಾ ಅಂತಂದ್ರೆ ಯು ಶುಡ್ ಹ್ಯಾವ್ ಆಲ್ ಯುವರ್ ಬಿಲಾಂಗಿಂಗ್ಸ್ ಲೈಕ್ ದಟ್. ಇಫ್ ಅಟ್ ಆಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇಸ್ ಪೊಸೆಸಿಂಗ್ 85 MeV, it has to come out with 85 MeV only, not less than that energy. Okay, ಇದು minimum. When electron is coming out, its energy should be at least 85 MeV. Now coming back to beta decay experiment. Beta decay experiment you can do even today also. There are so many devices to measure energy of the emitted beta particle. So when the beta particle energy is measured, it comes out to be, it is observed that it is very small, about 3 to 4 mega electron volt. See, I expected the electron to come out with 85 MeV, but in beta decay I saw only 3 to 4 MeV. Where is 85? Where is 3 to 4? And experimentally energy is 3 to 4. According to my assumption, 85. I should go with experiment. Therefore, my assumption is wrong. That means electrons never exist inside the nucleus. So conclusion. It means for electron to exist inside the atomic nucleus, its energy must be greater than or equal to 85 MeV. But electrons emitted from the nucleus in beta decay experiment have energies around 3 to 4 MeV. This discrepancy clearly indicates that electrons do not exist inside the nucleus. ಒಳಗಡೆ ಇರಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ. Okay, so this is about uncertainty principle application. This is also one of the expected question. Well, now I move on to the numerical problems part. An electron is associated with de Broglie wavelength of 1 nanometer. Calculate energy and corresponding momentum. Very simple question, very simple problem. Equation is this: lambda is equal to h by root of 2me. E is kinetic energy, m is mass, h is Planck's constant. I want E, so I square on both the sides and take E this side. So such type of small mathematical arrangements you try to convince yourself. All those explanations not required, and you are matured enough to make out all these things. E is equal to h square by 2m lambda square. Make substitution for h, m, everything and calculate. Answer you can get it in joule. 2.41 into 10 power minus 19 joule. As I told in my previous videos, you need to put energy in electron volt, and you know how to convert that into electron volt. Divide it by 1.6 into 10 power minus 19, you get the energy in electron volt. So it is 1.51 electron volt. And once you get energy, use the same formula, lambda is equal to h by p, because I need to find even momentum also. So momentum P equals h by lambda. Substitute for h and lambda and simplify. This is the answer. Well, this type of questions are very simple. Here you can save time, and this time you can utilize for lengthy answer type questions. Okay, so that is what is called time management. Well, dear students, I will stop the discussion of this particular part here. I come back to you with module 3 in my next video. Keep supporting me, keep sharing my videos with your friends also. Thank you very much.